Hey guys, this is a recording of the Chapter 6 review. I will go through each problem with their solutions. I will show how to do them and give you the correct answers. So let's get started with number 1. Number 1 says to solve the following triangle using the law of sines. If no triangle exists, state no triangle. If two triangles exist, solve both. And it gives us that A is equal to 70, B is equal to 55, and little a is equal to 12. So let's just start by getting a triangle. So I'm going to draw a triangle. And I'm going to label it ABC. Now your triangle doesn't have to look exactly like this, just as long as your angles correspond with the sides. So angle A is 70, and little a, or crossment, is 12, and angle B is 55. That's all we're given. And I need to solve this triangle, meaning that I have to find little b, little c, and angle C. Angle C is the easiest to find. All I have to do to find angle C is take 180 minus my two given angles, so minus 55, then minus 70. And I will get 55. So angle C is equal to 55. Now to find little b, side B, I will have to use the law of sines. And I will do that to solve for little b. So I will take the sine of big B, so sine of 55, over little b, and that will be equal to the sine of 70 over little a, which is 12. To solve this, I will cross multiply, so 12 times the sine of 55, and that will be equal to b times the sine of 70. Now we need to solve for b, so I'm going to get b alone, so I'll divide both sides by sine of 70. The sine of 70 on the right will cancel out. So b will be equal to 12 times the sine of 55 over the sine of 70. You can punch that into your calculator. Make sure your calculator is in degree mode since we're dealing with degrees. And that'll give us b will be approximately equal to 10.5. So right now I know little b, which is 10.5. Now I need to find little c, and I will do that by doing the same exact thing except using the angles for c. So I will take the sine of 55 over little c, we don't know what c is, and that will be equal to the sine of angle A, which is 70, so the sine of 70, over little a, which is 12. And again, to solve for c, I will cross multiply, and I will get 12 times the sine of 55, and that'll be equal to c times the sine of 70. Again, divide both sides by the sine of 70. Sine of 70's cancel out, and I'm left with 12 times the sine of 55 over the sine of 70, and I will again get c is equal to approximately equal to 10.5. Now, if you recognize that this was a nice isosceles triangle and that b and c were equal, that's awesome. If not, you're still fine by solving the whole triangle. For number 2, we're doing the same thing, but this time we're given an angle and two sides. So we have a side-side angle triangle. So I'll have to take myself through the fact tree that we are given. It is on your red sheet and it is also in your notes. So the first question is the angle given obtuse or acute? So let's get a quick picture, that way we know what we're looking at. Horrible triangle. Angle A is 39. Little b is 26. And little a is 20. So the angle given is 39. I need to see if that is obtuse or acute. Well, 39 is less than 90, so it is acute. So I'm on the right side of my tree. The next question is the opposite greater than or equal to the adjacent. Since my opposite, the side opposite of my angle, is 20, and my adjacent is 26, I'm asking myself, is 20 greater than or equal to 26? Well, that is a no. So I go down the right side of that end of the tree, taking me to three possible choices in which I have to know my height. So I have to find the height of the triangle. I do that by taking my adjacent side times the sine of theta. Well, my adjacent to my angle is 26. So I'll take 26 times the sine of my angle, which is 39. So I have 26 times the sine of 39. And this is about equal to 16.4. So I need to compare that height, the 16.4, with my opposite. So I need to look if my opposite side, 20, is less than my height. And that is not true, so I go to the next choice. Is the opposite equal to the height? So is 20 equal to 16.4? No, it is not. So I check the last option. Is the opposite greater than the height? So is 20 greater than 16.4? Yes, it is. So I know I have two triangles. So I will have a triangle with the first angle B that we find and with the second angle B we find. So let's go ahead and find the first angle B, and that's just a law of sines. So I will take the sine of B. We don't know angle B, so it's just sine of B over little b, which is 26, and it will be equal to the sine of A, which is 39, so the sine of 39, over side A, which is 20. And I will solve for angle B. So to start solving this, we will cross multiply. So I'll take 20 times the sine of B, and that will be equal to 26 times the sine of 39. To get sine of B alone, I will divide by 20 on both sides. And I'm left with the sine of B being equal to 26 times the sine of 39 over 20. And to find angle B, I will take the inverse sine of both sides of my equation. So the inverse sine of 25 times the sine of 39 over 20. And that'll give me about 55 degrees. So B is approximately 55 degrees. So that is for my first triangle. So that is B1 is equal to 55 degrees. So I'll put that into my triangle. And with that, I can find my first angle C. So 39 plus 55 is 94. Take 180 minus 94, and I get 86. So the first angle C is 86. And that is all three of my angles for my first triangle. Now, I also have a second triangle where it still has 39 degrees for A, and it still has 20 for side A. But it will have different angle B and angle C. And you find the second B value, so B2, by taking 180, so B2 is equal to 180 minus B1. So 180 minus B1 was 55 degrees. So 180 minus 55, which is 125. So B2 is 125. Which will then give us a second angle C. And we'll find that by taking 180 minus 39 minus 125, giving us 16 degrees as the second angle C. Now we just need to solve the rest of this triangle. And we have to do the same thing with the other one. So let's go back to our first triangle, and we have to find our last side C. So I'll do that by using the law of sines. So I'll take the sine of C, which is the sine of 86, over side C, and that'll be equal to the sine of angle A, which is 39, over 20. Then we just need to cross multiply, solve for C. So C times the sine of 39 will be equal to 20 times the sine of 86. Divide both sides by the sine of 39. Cancel it on the left. And C will be equal to 20 times the sine of 86 over the sine of 39, which will give me side C being equal to approximately 32. So my first triangle is solved. So let's go back to the second triangle. Now again, we were given side B. That does not change. That's still going to be 26. So the last thing we need to do is find little c for this one. So again, I'll use the law of sines. So the sine of C, so the sine of 16 over little c will be equal to the sine of A, so the sine of 39, over 20. Do your cross multiplication. I will get C sine of 39 being equal to 20 times the sine of 16. Divide by the sine of 39 on both sides. And I'm left with C is equal to 20 times the sine of 16 divided by the sine of 39, giving us C is equal to approximately 8.8. So I will label that on my triangle, and then I have solved both triangles. Now this next problem, we are solving another triangle, but this time we are using the law of cosines. Now these are a lot easier because we only have to deal with one triangle. So let's go ahead and get a picture of our triangle that we will be working with. We're given that little a is 117, little b is 66, and little c is 144. For this triangle, we have to find all of the angles. We're going to do that by using the law of cosines to find one of the angles, and then the law of sines to find another, and then just use 180 minus those two angles to find the third. So let's go ahead and find angle C first. So I'll use the law of cosines that says C squared is equal to A squared plus B squared minus 2AB times the cosine of C. And again, this is in your formula sheet, the red one, and you will be able to use this on your test, so you do not have to memorize this. So now we have to just fill in what we know. Well, we know little c is 144. So I have 144 squared Little a is 1/17, so I have 1/17 squared, plus little b squared, which will be 66 squared, minus 2 times AB, so 2 times 1/17 times 66, times the cosine of C. So it's time to do a little bit of simplifying. I'll do 144 squared first, which is 20,736. That'll be equal to 1/17 squared, which is 13,689, plus 66 squared, which is 4,356, minus 2 times 1/17 times 66, which is 15,444, times the cosine of C. Now I can start solving for the cosine of C, but first let's add 13,689 plus 4,356, giving me 18,045. Still subtracting 15,444 times the cosine of C, and that is still equal to 20,736. To solve for cosine of C, I am first going to subtract by 18,045. Remember, I cannot subtract these because the 15,444 is multiplied by cosine C, so that is why I have to get rid of the 18,045. So I have to make sure I do that to both sides. And I get 2,691. And then it's still going to be equal to negative 15,444 times the cosine of C. My last step to solve for the cosine of C is divide both sides by negative 15,444. Cancel out on the right side, and I will get the cosine of C equal to some long negative decimal that I really don't need, because all I'm worried about is what angle C is. So I have the cosine of C equal to 2,691 over negative 15,444, and to get angle C alone, I take the inverse cosine of this fraction. And when I take the inverse cosine of that, I will get angle C being equal to approximately 100 degrees. So I now know that angle C is equal to 100 degrees. I'm going to use that with the law of cosines to find another angle. Let's go ahead and find angle A. So I'll take the sine of 100 over 144, and that'll be equal to the sine of angle A over 117. Let's cross multiply. I get 144 times the sine of A equal to 117 times the sine of 100. Divide both sides by 144. I get the sine of A is equal to 117 times the sine of 100 over 144. And I just take the inverse sine of that to get A equals 53 degrees. So my last thing that I need to do is find angle B, and I will do that by taking 180 minus 100 minus 53, and that'll give me my last angle, angle B, which will then be equal to 27 degrees. So we have solved this triangle. For number 4, we are given another triangle that we're going to solve using the law of cosines. So let's get our triangle first. Angle B is 66 degrees. Little a is 17, little c is 12, and we don't know little b. So for this I have to find two angles and little b. So the first thing I'm going to do is I'm going to use the law of cosines to find little b. So I'll use b squared equal to a squared plus c squared minus 2ac times the cosine of b. So I just need to fill in what I know. I don't know little b, so I'm left with b squared equal to 17 squared plus 12 squared minus 2 times 17 times 12 times the cosine of b, so the cosine of 66 degrees. And all I have to do on the right side is just plug all of that into my calculator, and I'll get b squared is equal to 267.05. And then my last step to find what b is just take the square root of both sides. So b will be approximately equal to 16.3. So I found little b, which is 16.3. Now I need to find my two missing angles, and I will do that by using the law of cosines. You could use the law of sines, whatever you would like, does not matter, but I'm going to use the law of cosines. So I'm first going to find angle C. So I'm going to use the law of cosines that says c squared is equal to b squared plus a squared minus 2ab times the cosine of c. So I'm going to fill in what I know. I know that c is 12, so I have 12 squared equal to b squared, which we just figured out is 16.3, so 16.3 squared, plus 17 squared minus 2 times 17 times 16.3 times the cosine of c. So after some calculation and subtraction, I will get negative 410.69 equal to negative 554.2 times the cosine of c. Divide by negative 554.2 and take the inverse cosine of that, and you get c equal to 42 degrees. And last thing we need to do is find angle A, and angle A will be equal to 180 minus 66 minus 42. So A is equal to 72 degrees. So number 5, we need to find the area of the triangle and round to the nearest square unit in our triangle. Gives us that angle C is 42 degrees. little a is 4 feet, and little b is 6 feet. So to find the area of this triangle, I'm going to use the area formula 1/2 times my base times my height. Now I know that my base is 4, but I need to find my height. And we're going to use the height equation, the adjacent times the sine of the angle. In this case, I'm going to use 6 times the sine of my angle, which is 42. And all you have to do for this is just plug it into your calculator, and you'll get approximately 8 feet. For number 6, I'm finding the area of a triangle again. This time, I'm given angle A is 22 degrees. Little b is 4. And little c is 5. Again, going to use the area equals 1/2 base times height. Now, since we're not given the base, I can rearrange my triangle however I want. It doesn't matter. I can flip it on either side, and either side can be the base, and either side can be therefore the adjacent. So I'm just going to take 1/2 times 5 times 4 times the sine of the angle, which is 22 degrees. Multiply all that in your calculator, and you'll get approximately 4 feet squared. Number 7, we're finding the area of a triangle again, except this time we're not given any angles. It's just 3 sides. So we're going to have to use Huron's formula to find the area of this triangle. And that formula is the square root of s times s minus a times the quantity of s minus b times the quantity of s minus c, where s is equal to 1/2 the parameters, so a plus b plus c. So the first thing I need to do is find what s is equal to. So s is equal to 1/2 times 2 plus 4 plus 5. So s is equal to 3. I'm sorry, 11/2. My bad. So now to find my area, I will just plug everything I have into my formula. So a will be equal to the square root of 11/2 times 11/2 minus 2 times 11/2 minus 4 times 11/2 minus 5. And again, I'm taking the square root of all of that. Punch that in your calculator, and you will get your area being 4 meters squared. So number 8, I'm finding the area of a triangle again. Again, 3 sides, so I'll have to use Huron's formula again. So the first thing I need to do is find my half of the perimeter. So s is equal to 1/2 2 plus 2 plus 2, which will be 3. I will then need to put that into the formula a equals the square root of s times s minus a times s minus b times s minus c. So a is going to be equal to the square root of 3 times 3 minus 2 times 3 minus 2 times 3 minus 2. I'm going to give the square root of all of that. Since 3 minus 2 is 1, I am just left with the square root of 3, which will be my area. Number 9 says, a lamp that is perpendicular to the ground sits on a straight line between two fence posts that are 400 feet apart. The angles of elevation from each fence post to the top of the lamp measure 30 degrees and 50 degrees respectively. How tall to the nearest tenth of a foot is the lamp? So first thing for part A is we need to draw a picture. So we have this lamp. Here's our lamp. And it is in between two fence posts that lie on a straight line. So here are our fence posts. And we know that the fence posts are 400 feet apart. And we also know that the angles of elevation from each fence post to the top of the lamp are 30 degrees and 56 degrees respectively. So the first angle of elevation is 30 degrees. And the second angle of elevation is 56 degrees. And our goal of this problem is to find the height of the lamps. That's what we're looking for. We're looking for H. Now, just so we have some reference, I'm going to label my triangle A, B, and C, making this side little a, this side little b, and the third side, the 400, will be the little c. We need to find the height of the lamp. So the first thing we're going to do is we're going to find side A, and I'm going to use the law of sines to find side A. So I'm going to take the sine of A, so the sine of 30, over little a, and that'll be equal to the sine of C, but we don't know angle C, but that's easily found. Just take 180 minus 30 minus 56, which is 94 degrees, so the sine of 94 degrees over 400. Cross multiply to solve for A. I have A times the sine of 94 equal to 400 times the sine of 30. Divide both sides by the sine of 94. And I get A is equal to 200.5 feet. So I know little a is 200.5 feet. Now with this, I now have enough information to find the height. I can use SOHCAHTOA from way back when to find the height of my triangle. And I'm going to focus on this triangle right here. So this is the triangle we're focusing on. And in respect to 56 degrees, A is the hypotenuse and H is the opposite. So since I know the hypotenuse and I'm looking for the opposite, I'm going to use sine, because sine is opposite over hypotenuse. So knowing that the sine of an angle is equal to the opposite over the hypotenuse, I can find my height. So I'm going to take the sine of 56 degrees, And that will be equal to my opposite, which is h, over the adjacent, which is 200.5. Multiply by 200.5, I get h is equal to the sine of 56 times 200.5, and I get my height equal to 166.24. Number 10, we're given a polar coordinate 2 pi over 3, and we have to find the rectangular coordinate, the x, y values. Remember that a polar coordinate is given to us with the radius and then the angle measurement. So the radius of this polar coordinate is 2, and the angle measurement theta is equal to pi over 3. And we need to convert this polar coordinate into rectangular. And we're going to do that by using the fact that we know x is equal to r times the cosine of theta, and y is equal to the radius times the sine of theta. And these are both on your formula sheets, so you will be able to use them for your test. So I just need to fill in what I know. I know my radius is 2, and I know that the theta value, the angle measurement, is pi over 3. Well, the cosine of pi over 3, using your unit circle or the hand trick, whichever you prefer, is 1/2. So I'm given 2 times 1/2. So x is equal to 1. Now we go over to y. Y is equal to the radius 2 times the sine of the angle, pi over 3. The sine of pi over 3 is root 3 over 2, so I have 2 times root 3 over 2, which is just root 3. So y is equal to root 3. So my rectangular coordinate is 1 root 3. For number 11, we are given a rectangular coordinate, negative 1, 1, and we need to find the polar coordinate, r and theta. So I need to find what r is and find out what theta is. I'm going to find r by using the Pythagorean theorem, or r is equal to the square root of x squared plus y squared. So that's how I'm going to find my radius. And I'm going to use the fact that the tangent of theta is equal to y over x. So I'm going to use those two things to find my radius and my angle measurement. So let's find our radius first. So r is equal to the square root of x squared plus y squared. My x is negative 1, so I have negative 1 squared, plus my y value, 1 squared. Well, negative 1 squared plus 1 squared is 2, so r is equal to root 2. So now let's go ahead and find our angle measurement. The first thing we need to do is find out what quadrant we're going to be in. Well, if we would plot negative 1, 1, we know that we are in quadrant 2. So I'm going to be looking for the angle that is in quadrant 2. So since I know y and x, I can take the tangent theta being equal to 1 over negative 1, or just tangent theta being negative 1. So I need to look at my unit circle and find out which angle in quadrant 2 produces the y-x ratio of negative 1. And that is the angle measurement 3 pi over 4. So theta is equal to 3 pi over 4. So that gives me the polar coordinate root 2 as my radius and 3 pi over 4 as my angle measurement. Number 12 says a heavy crate is dragged 50 feet along a level floor. we need to find the work done if a force of 30 pounds at an angle of 42 degrees is used. This is a vector problem. This is a problem for one of the last lessons in the chapter. And in that lesson, we found out that the work is equal to the magnitude of the force times the magnitude of AB, so the distance traveled, times the cosine of our angle. So we just need to fill in what we know, substitute in what we know. Well, we know that the force was 30 pounds, so 30, times the distance we traveled, which was 50 feet, so times 50 feet, times the cosine of the angle measurement that was given, so cosine of 42 degrees. Plug this into your calculator, and you get W is approximately equal to 1,115 foot-pounds. For number 13, we have to use the polar coordinate grid to plot and label the polar coordinate points that are given. So, point A. A is equal to 210. So my radius is 2, and I am at 210 degrees. I know that 210 degrees is in the third quadrant, so this is my 210 degrees line. So I know I will be on that line. Since my radius is 2, I will go out from the center 2 spaces, putting me right here for point A. Point B is at -1, 3 pi over 2, so the radius of -1, angle measurement of 3 pi over 2. 3 pi over 2 is this line right here. But since my radius is negative, instead of going out on the line, I will go the reverse direction, -1, putting me right here for point B. Point C is -3, negative pi over 4. So my radius is -3, angle measurement is negative pi over 4. My angle measurement is negative, so instead of going counterclockwise, I will go clockwise pi over 4, putting me on this line right here. This is my negative pi over 4 line. And since my radius is negative, I will go the opposite direction, -3 on the same line. So out 3 points and 3 spaces, and it puts me right here for C. D is at 2 pi over 4, so radius of 2, angle measurement of pi over 4. So my pi over 4 line is right here. I need to go out 2 spaces, putting me right here. That is point D. My last point is E, which is 260 degrees. My 60-degree line is right here. And I need to go out 2 spaces. So out 1, 2. Putting point E right there. Number 14 says, given the initial point P1 equal to -1, the terminal point P2, 5, -3, I need to write the vector V in terms of I and J. So this is an IJ vector that is not having an initial point at 0, 0. So I need to find out the distance for my X values for my I coefficient and the distance for my Y values to find my J coefficient. And I will do that by taking x2 minus x1 I plus y2 minus y1 j. And remember, with these problems, it is very important that x2 and y2 come from P2. So I will take x2, 5, minus x1 which is 2, so 5 minus 2, I, plus y2 minus y1, so negative 3 minus negative 1, j. 5 minus 2 is 3, so 3i. Then negative 3 minus negative 1 is negative 2, so I'll have minus 2j. So 3i minus 2j is my vector. Now I need to find the magnitude of this vector. And I find the magnitude by using the distance formula, but since our ij vector has a initial point of 0, 0, I'm not really worried about those other points, so I will just use the magnitude being equal to the square root of a squared plus b squared. So the square root of 3 squared plus negative 2 squared. So the square root of 9 plus 4, which is equal to the square root of 13. So my magnitude of vector v is equal to root 13. For number 15, we're given two vectors. We're given u is equal to 5i plus 2j, and vector v is equal to I minus j. Part A says we're going to find the dot product of u and v. So remember, the dot product says we multiply the I coefficients plus the product of my j coefficients. So to find the dot product of u and v, I take 5 times 1 plus 2 times negative 1. 5 times 1 is 5, plus 2 times negative 1, which is negative 2. So my dot product is 3. Part B says to find u plus the scalar multiplication of 2, so 2 times the vector v. Well, I know that u is 5i plus 2j, and I need to take 2 times vector v, which is I minus j. So nothing happens to my 5i plus 2j yet. So plus, then 2i minus 2j. Then I need to combine my I components and my j's. So I have a 5i and a 2j giving me a 7i, then a 2j and a negative 2j, which is 0j. So I'm just left with 7i. For 16, 17, 18, and 19, we're doing some vector operations using v and w. So 16 is just a v plus w. So I'm taking I minus 5j plus negative 2i plus 7j, giving me negative I plus 2j. Number 17, I'm doing v minus w. So I'm doing I minus 5j minus negative 2i plus 7j. So I'm doing I minus 5j plus 2i minus 7j, giving me negative 6i minus not negative 6i. It will give me an I plus a 2i, which is 3i minus then negative 5j, negative 7j, which is 12j. For number 18, I'm doing 6 times vector v minus 3 times vector w. So 6 times vector v is 6I minus 30j. Then I'll do minus 3 times vector w, which is negative 6I plus 21j. This will give me 6I minus 30j plus 6I minus 21j, giving me 12I minus 51j. Number 19, I'm finding 2 times the magnitude of w. So I need to look at w and do my a squared plus b squared. So I'm taking 2 times the magnitude of w, which will be equal to 2 times the square root of negative 2 squared plus 7 squared, which is equal to 2 times root 4 plus 49, so 2 times root 53. So that finishes up the review. Thanks for watching. Hopefully this helped you out. If you did well on this review and you know everything in this review, you will do well in the test. So go ahead and take a look through this one more time. Make sure you're good on anything. And if you have any questions, you can stop by tomorrow at any time before class and ask me, and I will be sure to help you out. Good luck, guys.